Woohoo.
All right, welcome to our first ever monthly OSHWA talk. So what we're doing, hoping to do with this series is,
Ooh, Lee, you're muted. Are you intentionally muted?
no, I'm getting an echo of myself and I don't know where it's coming from.
Oh no.
All right,
Yeah.
all good. So we're hoping to do with this series is to have folks who are excited about sharing their open source projects come in and chat with us about those projects and about the communities that they're involved in. So my name is Lee Wilkins. I'm the summit chair for the Open Hardware Summit.
Yeah, hi, I'm Sid May. I'm the community manager for OSHWA, and we're actually kicking off the monthly talks this month as part of the Open Hardware Month, which is October. So be sure to check out the Open Hardware Month website to see all the events that are coming up. And we're really excited to get things started with Paul.
Hello.
So welcome, Paul McClay.
Thank you.
Do you want to start by just telling us a bit about yourself and who you are, and maybe a little bit about the project you'll tell us about today?
Um, I'm just some guy with a tendency to be distracted tinkering on stuff. Um, in school I did computer engineering and physics and did some sysadmin work for a while, and then went back to library school, and then did computers and libraries for a while, and some other stuff. And at the moment, nobody's expecting me to do stuff that they're paying me for. So it's easier to be distracted and do silly things. Um, and that, so I tried a thing and it worked, and that just sort of escalated. And like it was in the middle of COVID at the time. So it seemed like there's a lot of kids that aren't in shop class. Might as well share
Why
how
don't we
to.
back up a little bit and you can tell us about what the thing you tried is?
Um, so, well, do we already know that what I'm talking about is a little CNC machine? Okay.
Yeah,
Um,
I know, but let's share it with our viewers.
okay. All right. So I guess I kind of assumed there was context. Sorry. Um, so I made a bit of hardware, and then I thought publish the design. So it's a very small little CNC, router mill thing with a kind of hit on a combination of components that, as far as I know, is the lowest cost of materials um, that I've seen for building one, other than getting lucky with a dumpster. Um, and I think kind of remarkably, it's actually pretty good for precision, uh, doing like very small parts and fine pitch circuit board milling. And small parts is good because it's not going to make big parts because it's small.
Yeah, I've been
And
involved with a number of maker spaces that all have, CNC mills or routers, and it's always kind of like a big deal to figure out how to train people on them and figure out how to use them, and they're usually pretty big pieces of equipment. And you mentioned libraries. So I'm just wondering if like your experience working with libraries or experience working with Makerspace kind of inspired you to make this project.
um, I think the like libraries are essentially a public facing, or some community facing operation, and um, that's it's a bit of an intentional ethic in the community, and I suppose some of that rubbed off.
Cool. So what like do you have any background in like mechanical engineering or something that would kind of lend itself to the skill set to design and build this CNC machine?
um, Other than sort of wishing I did, no. um,
That's
I
kind
have.
of amazing if you have no background in it and you just were able to succeed to this degree.
Yeah, I mean, I grew up in a house that had tools and materials, and so I learned the habit of, need a thing, make it to some degree, with being limited to kind of crude methods. And whenever I, look at machining or something, I feel a little bit jealous because that's really cool. But where I am now, I don't have space. Like, I live in a condo, I don't have a garage that can be full of chips and sawdust and whatnot. So I think for a really long time, like decades, I'm sort of had in the back of my head this, like there are, I don't know if you've seen the many decades old Unimat small lathe and mill combination. Really cool. I might almost have space for that. They've gone on and made some other really small, simple stuff that I almost have space for. I almost got one at one point. And, before I got around to getting one, I accidentally built one.
What were some of the more challenging aspects of designing and building the Miniamil?
Well, one was just a really long period of kind of rolling ideas around, looking for just being distracted from whatever I was supposed to be doing, kind of cruising AliExpress for parts and whatnot. Then once I got going, one, really like a specific, pretty hard challenge at the time that completely blindsided me was that I made this thing like an XY table, 2 axes, and because inertia and another story on the side, I thought I was going to have that on vertical with the z-axis this way, and the vertical axis didn't work. Like, it could drive up, but it couldn't move down, which is unexpected. You usually expect gravity to be your friend. And I thrashed on that for a while and thought there must be something I don't know, and thrashed on that some more, and then found in some guy's fairly recent PhD thesis lit review, it says, everybody uses lead screws and there's remarkably little analysis of the dynamics, and here's a corner case that fails. His PhD is kind of fancy stuff that's out of scope, but his literature review clued me in that if you have a shallow pitch lead screw, like actually just using a screw instead of something that's a purposefully made lead screw, and you're pushing it in the direction that it's moving, like, moving down with gravity, and a couple other conditions, it's going to chatter hard. And there's a set of conditions where like that just happens. It's the physics. So there wasn't any way I was going to get around that. So that eventually that turned turned those 2 axes flat. And hopefully, wasted less time on trying many things that didn't work. Because if I have to counterbalance something, it may as well be the big, heavy, slow axis. So I put the big, heavy, slow axis vertical, and that worked. And eventually, when it started getting everything all together, it worked remarkably well.
That's awesome. I really like that you managed to find the solution like in someone else's work, and I feel like that's like really what the philosophy of open source hardware is really all about. So it's really cool.
I mean, this is all finding solutions in other people's work, mostly, and then gluing stuff together. I think to your early question, if some involvement in the library community prompted me to share stuff, I think part of the answer to that is what you just said, finding answers in other people's work. Just so much of that, that if I come up with something that I didn't find out there, I may as well put it back in the same pool.
What were there any projects in particular that inspired you, or did you just sort of stumble upon individual solutions as you worked through the problems?
Well, the desire for the thing I don't have, for one, just the general category of mill or CNC mill, but mill is kind of what I was looking for. Specifically, well, I guess part of being different is you can't really follow too closely. Before I did this, I did a kind of a silly one-off project where I managed, I tried making this with the linear actuators in CD-ROM drives, which are, they're great toys for making CNC stuff because they're easy to find in dumpsters and they're free and fun, and you can make things that don't have to be terribly rigid or strong. And I kind of went down the rabbit hole of trying to make a mill that can actually cut like something harder than floral foam, and got some success. Hackaday published that. At the time that I was writing that up, I wasn't aware of any other examples, and no others have turned up. So that, that's kind of fun, but it's pretty useless because the capability is limited, like really limited. And it was all about sort of using found parts and stuff, and nobody else is going to find the same pile of parts. So, but the whole time I was working on that, the major frustration was that, I was like, these CD-ROM linear actuator things are crap. And I was wondering, problem is that if I start tinkering with upgrading that quickly turns into just getting different axes, which quickly turns into just, getting a mill instead of playing this intellectual game of trying to make it work with the CD parts. But the whole time I was doing that, I was also kind of thinking, is there a small next step up? And cruising cheap parts on AliExpress and whatnot, and eventually found a combination of motor and lead screw that was like $5, and started noodling ideas for putting that together. So I guess the question was kind of, was there anything that in particular that inspired this? And coming around to the shorter answer is sort of back in my head thinking about what would I do if I were doing something different to avoid the essential limit and frustration of the project I was doing at the time, and eventually kind of came up with a thing to try, and tried it, and kind of surprised at how well it worked. So I kept rolling.
So for you, it sounds like it's really about like the process. Like what interests you is not the end result of the mill, but the process of like creating it either through salvage or really cheaply, or like through whatever methods that you come up with.
Yeah. Like the direct way to the end result is go buy one.
Yeah.
And I started putting effort into writing this up because I was kind of surprised to come up with a result that actually seemed like it might be interesting to more people than just me.
Do you have any like particular parts of the design that you think are really clever or interesting, or that you're really proud of?
Actually, I think there are several little parts of it that like I didn't find anywhere else and could be useful for other projects that I tried to write up. For one, just the linear slide, a thing that moves in exactly one way and no other way. I came up with a design like, assuming you have access to a laser cutter. This is all assuming you have access to a laser cutter. If you don't, but I think
it's the old like maker challenge of need a tool to make a tool, right?
Yeah. To digress a little bit, I have this idea that I think access to a laser cutter is becoming less uncommon, like schools and libraries and stuff like that. And
Sure.
I think there's increasingly many people for whom the answer is, why, yes, I do have access to a laser cutter, and that's even easier than having access to like conventional tools, because I don't have any place to make sawdust.
Well, I mean, I think that a lot of people even have more access to a laser cutter than they have to like a 2D paper printer, you know, because people don't buy those these days. And like every school, every library, like if you look, you'll find a laser.
So anyhow, that's all. Assuming you have access to a laser cutter, I came up with a design for the linear stage that is almost free. Like using 3 bearings, which are less than $1 each, and 6mm rods seems like a popular size to use in printers and stuff like that. So that's scavengeable, or you can buy it. And well, the material I've been using, like I started with the most limited material, in other words, the cheapest stuff I could get, to see how far I could get with that, and I haven't had to step up. So it's 1/8" hardboard is almost free if you like per unit area. Like if you go to your local big box place, assuming they sell 4x8 sheets, and get it cut down to something that fits in your laser printer, then your cost for this much of it is 50 cents. I'm sure anybody will come up with different actual numbers when they go price stuff, but so anyhow, the point being that the cost of materials is almost nothing to make a linear stage, which is usually something that you kind of have to spend some money on parts for, or a complete unit. And in the course of trying to write up how to build the whole thing, I ended up breaking out just a linear stage and how to build that as an entirely separate project. So, linear motion for something closer to free is out there. And I think, well, one of the things that I was looking for was, how do you securely clamp onto a Dremel, like a rotary tool? And well, part of the answer to that is there's lots of 3D printed parts out there, but another kind of basic constraint I set for myself is that if you need a bunch of fancy tools to make the cheap tool, that's kind of pointless, because if you have the fancy tools, you don't need the cheap tool. So starting with using a laser cutter, kind of the design rule was, that's the only fancy tool. I didn't use any 3D printed parts, because I don't, right? So I came up with eventually a way to make a clamp onto a Dremel tool using just flat, clamp onto this round thing with flat parts. Actually, I have that within reach. It's a little hard to show, but it's
I love this mechanism. That was one of the parts that was really like distinct on your design.
Yeah, and this is these are little kind of a Spanish windlass wheel that you can crank down as tight as you want until you start breaking stuff. But if you take a little time to get it adjusted, you can get it so that it just has a little snap over point where it's like microscopically too small, so you have to sort of violate space to get it to snap over there, and then it's tight. So that works really well, and I haven't seen it. It's just a thing that I haven't seen anywhere else. The usual way to take flat parts off your laser cutter and stick them together is kind of bolts and T-slots and nuts, and that all takes up space inside. Here's your part, and then you have these fasteners sticking into it that uses up space in the middle that you can't use for other stuff. And, you know, I don't think that it's entirely unique, but I kind of stumbled into an arrangement that, you know, to tab into tabs and slots and screws that takes up almost no real estate in the interior part so that I can have features on the inside. And it makes a lot more sense with a picture. I don't know if you look just at the end of that here. This is just like, this is a machine screw edgewise into thin hardboard, which shouldn't hold at all. Like, that's the wrong way to do anything about fastening, except that it does hold because the tab is split, stuck into the slot. So the slot keeps the sides of the tab together so you can drive a screw down the middle of it and it doesn't spread because it can't. And one of the parts that I was really surprised about is that screws actually hold well enough that way that it works. And then I, you know, design so that I'm not pulling straight out on the screw, so that these joints are all loaded in compression or shear, and it works. And it, you know, it's like, it's not part of the standard repertoire I see on how to put laser cut parts together. So that's the thing that, you know, it seems like that would be easy for people to pick up who are making anything.
Yeah, that's a really cool
making. You know,
have you?
It's easier to. I was just going to say, like, the other thing is, like, practically free, fine adjustable anti-backlash connection to the, you know, like, I have this lead screw, and lead screws have backlash, and that's what you have to go buy anti-backlash nuts for, except I didn't want to have a long parts list, so I came up with you know, just using another laser cut part and a bent up paper clip can adjust backlash down like under a thou, and it works. And it, like, that's almost zero cost. It seems like that could be a thing that people could use. It's really that the way I did that was kind of a product of seeing how Sherline does it with their mini mills. And so it's not quite identical, but I don't think I would have got there if I hadn't looked at a Sherline. So, you know, sort of where ideas come from.
Mm-hmm. Have you seen anyone in the community reproducing your design or riffing on your design or making changes that you thought were interesting in your design?
Really good question. Starting with the ripping on question, you know, people rip on stuff for sport. I think a really important metric is that when I read critical comments,
on your design, not ripping on your design, but that's all. You can answer any question you want. I meant it in the positive. You know?
Okay. All right. Well, anyhow, I just, like, for my perspective, one of the metrics is, I like, when I read critical comments, they don't kill sort of my perspective on the project. It's not like, oh, right, that was a bad idea. It's like, okay, it doesn't fit you, but your comment doesn't kill my project. Riffing on, I know there's a couple people that are in the process of building one that have gotten back to me about it anyhow. I think sort of part of why I'm still poking at this is that I thought a while ago that a kind of a validation for the idea that I say, I think anyone can build this, you know, by assembling parts instead of an idea, go to the shop and fabricate it. And the validation of that is when someone actually builds one. And, you know, I don't have an example of a working unit in someone else's hands yet, which is sort of, you know, kind of hoping to see that.
Yeah, and for sure.
I have published the CAD, so if anybody wants to, they can riff on that.
Are there any kind of components that you're hoping to add to it as time goes on?
Yeah, well, this that I grabbed here, because I can just grab it and wave it around, is a entirely different Z-axis from what I've published so far that uses a cheaper motor and gets rid of the silly counterweight, which is a side effect of going to the Midwest Rep Festival and actually talking to a lot of people about it. And I think that sort of shook loose some of the things that had become too settled in my head. And so when I kind of, got home thinking about that, it's like, oh, I should do Z totally differently, because I was doing just the wrong thing, because I was lazy at the point where I thought, okay, I need a Z axis. I'll just take one of these, the linear axes that I did for the XY stage. I'll just slap one up for Z and carry on and forgot that I had deferred actually designing a Z axis until later. So I needed some help to remember that, oh, I can do that differently. Maybe I should do that differently.
Mm-hmm.
And I have less progress on other ideas because I took a few weeks to validate that it worked. The Z-axis worked well enough for, I want to be able to mill circuit boards, and I want to do fine pitch milling on circuit boards, which requires pretty tight control of the Z-axis. And it took a while to validate that that would work with the new style thing, for reasons that were entirely up to me, because I was thinking about it wrong. It actually works fine.
What kind of processes do you use to validate the performance of a new part?
I heard most of that. What kind of something do I use to validate?
What kind of processes do you use?
I try to make something that seems like it would be challenges some particular capability that I want the machine to have. Mm-hmm. So, to validate that, yes, I can mill circuit boards with this, I just put together, in the first place, just grabbed someone else's breakout board for a fine pitch part and succeeded, and fiddled around with that. But I'm not actually in the middle of a circuit designing project at the moment, so I just did a little demo bit. Actually, I don't know if you can see this. I think, for focus purposes, you see it all, this little thing here? I taped some bits onto a quarter for scale.
Yeah, we can see. Yeah.
That's sort of the scale of parts. And for, I think, the first project that I did to say, can I make small parts, was a little differential gearbox,
mm-hmm.
which kind of started with, this might actually be the answer to your question. What's a thing that I can't make with a 3D printer or a laser cutter? Like, why does anyone need a CNC mill? Mm-hmm. And bevel gear was the first thing I tried. Like, can I make a bevel gear? Because you can't do it with a laser cutter, because it's not all straight. You have to be able to have a bevel, and not so great with at least a common 3D printer that people are likely to have, because the two problems are just spatial resolution, and that the material is stuck together in layers of filament, and that limits the ultimate strength of it. And little gears have little teeth, so being able to make it out of a solid piece of material, that was a validation test. I got a nice little gear, and then I just kind of kept rolling and built a little differential box. That was also a test of controlling runout, so that my bit isn't doing this, but spinning out a point. That has been a kind of a running side project that I think I've actually got pretty well solved now. So, part of making this was working with trying to minimize run out, but also dealing with having a sloppy, cheap tool. When eventually I
was
got
gonna ask also, like,
run out better solved.
I was gonna ask what the most like interesting or complex part you've made with the mill is.
Well, this is an assembly, and when I got the capacity to do fine detail down better, I went back and made it smaller. So I don't know how much you can see of, inside the little yellow part in the middle that's smaller than my fingernail, there's 4 bevel gears.
That's tiny.
And it,
wow.
There's 4 bevel gears, and there are 2 pairs, and that's the big one. So there's a smaller one that fits in the ring of that yellow piece. And, for scale, that's small compared to my fingernail or a quarter.
Yeah, that's tiny.
Which means that the feature sizes are even smaller, like, decimal millimeters. And that kind of scale, making something accurate to, decimal or sort of like half a decimal millimeter accuracy is something that's a little hard to do on other, like the cheap mills that you can just go buy.
Yeah, absolutely.
I don't see people doing precise work like that with them.
So do you have any advice for someone who's like maybe thinking about a similar project or maybe coming at a project from a similar perspective to you?
Well, I think I think in sort of like 2 different directions. One is just, get started and be prepared to make, 3 things or 7 things that fail. And each one is a lesson on how to, what to do with the next one to try and get closer. And it's okay to make something that doesn't work, because it's how you learn what you need to know to build the thing that's somewhat closer to working. And the other side of that is, trying to build things, like trying to save money by designing and building stuff yourself is usually kind of backwards, because the real thing is actually designed by people who've had some experience and are manufacturing it efficiently. And if you actually need the result, you should go buy the result. And a lot of what I learned from trying projects like this is I learn about, all of the things that make the more expensive product, actually worth that, because trying to reproduce that is hard.
Yeah, that's really, really good advice.
That's sort of an upfront, am I going to go this way or this way? And, the sort of the middle path just is kind of a marsh that gets bogged down, and eventually you have to choose a way.
Yeah, for sure. Where can people go if they want to learn more, or how can they get in contact with you, or if they have questions? Where do you want to direct people to?
Pretty much, I've been publishing everything about this on Hackaday. So that's hackaday.io/PMC, like the capitals in my name. And, if I guess I were better prepared with the multimedia arrangement, I would have a lot of pictures from that here, because a lot of this is much easier to show than to talk about. So most of what I would want to show, I end up making little videos. So, because then, the things that I'm saying here that sort of are a lot of words to try and say something that ends up not really making sense, that's a little video. And then like, oh, okay.
Well, we'll definitely put the links
So
to your
academic.
Hackaday page and direct people to you. And yeah, like I think we're really excited to see what's next because yeah, the project is really cool, and I love that you can produce such an expensive tool so cheaply. And I also really loved hearing about your kind of philosophy behind it to just like see if you could make it into these salvage parts. I love making stuff out of salvage parts, so that's really a lot of fun. But yeah,
Yeah.
do you have
And
anything else to
I've tried
add
to
for us?
put out fairly complete information.
Mhm.
Anything else to what?
Oh, I just said, do you have anything else to add or share?
Well, when I thought about publishing this, because like it was COVID, and I thought maybe this would be useful, I've ended up trying to share complete information pretty much in the open hardware spirit. So rather than just like, hey, here's this thing, and you can't have the CAD. The CAD's out there, and uh, it's open hardware in the reproducible sense. I think I've got some more ideas that are sort of growing out of this that might get interesting in the future. In part because I picked up a 3D printer since I started working on a design without a 3D printer. So I think, in the one fancy tool rule, going with 3D printing instead of laser cutting is going to be a different direction. And I don't really have much to show yet, but I have some promising, sort of I'm trying to make the bits and pieces, like the functional, can I make something like this and does it work? I haven't integrated that yet. So, there's
Stuff in the
there's
works.
some potential that, yeah.
Awesome. Well, I think yeah,
So I think
we're all
since this has just been me talking, everybody should go look at pictures.
One last question I was wondering before we wrap up for today. Beyond doing a CNC mill concept, are there any other kind of fancier machines that you have been thinking about how you could approach it in an open hardware sense?
I'm sorry, Sid, I got about 80% of that, which is almost enough to understand the question, but not quite.
My apologies. I'll try and I tend to be a mumbler. That's on me. I was just wondering if there's any
It
other
sounded more like connection.
larger closed source machines that you are kind of thinking of ways that you could recreate in an open source way?
I think sort of no. There are other machines that are, obviously most CNC mills are larger, and there are some that are also small. And they are different, and they already exist, and I don't have to replicate that. I think kind of where this project got interesting was finding a sort of a different corner in the combination of trade-offs that seem to be underexplored, and finding that, yes, like there is a different combination of trade-offs that has some potential. So that's kind of where I went. I don't need to reproduce what other people have already done really well.
Yeah, that totally makes sense. I think you've really found a very unique section that I don't think anyone really thought there would be a mill of this size, of this cost, that could do such precise work. I just looking through the photos of it and seeing how precise the mill can get is so impressive. I'm absolutely blown away, especially in the sense of like working on boards with it. That's really smart. But yeah,
I'm kind of blown away too. It was that wasn't my expectation when I started with the basic idea. The fact that it could work at that level of precision was a total surprise.
Mhm. That's always amazing to be surprised by your own work. It's such a good feeling. Well, thank you so much
Especially on
for
the
taking the
occasions when
time
it's a
to chat
positive
with us
surprise.
today.
You're
It's
welcome.
been like a real pleasure to hear all the details, and definitely we're going to direct people over to your Hackaday page, and we really look forward to seeing what comes next.
Yeah, the Hackaday page will be a lot better than just like my talking head.
Yeah, for sure. Well, thank you so much.
Thank you so much for being the
You're welcome.
first monthly talk, and we'll be keeping an eye on what you're coming up with next and sharing it with the community. So thank you again.
Yeah, and thank you guys for making the community.